Hey, how's it going? So in the last video that I made, we cleaned up these parts of speech here. And these, if you didn't watch that video, they're just very, very short examples that establish a part of speech based on a single word, because that's what we're teaching in the program. It's parts of speech and how they fit into sentences. That's hopefully, if I expose a student to enough of that, then they'll learn a little bit of English. So you can see what this looks like here. So here's our part of speech, and then here's our example. Part of speech, example. Part of speech, example, etc., etc., etc. So let's go in and start generating this. Should we use Jupyter Notebook? No, I like the autofill here, so let's do this. So we're going to, and now I've done this multiple times, so there might be something called build curriculum. So build curric.py. Didn't find anything. Okay, I think the first thing that we want to do is we want to combine these part of speech examples here. So let's say path equals, boom. The backslashes are giving us a problem, so we'll put the R there. Now list all files. You go away, you go away. All right, import that. Import JSON. And then we just need to read this data in. So my files equals list all files of path. And for file name in my files. Here, let's just take a look at it. What we've got, run. All right, looks pretty good. So we're going to say my data equals JSON.load. Thank you. No, not thank you. That's not what I wanted. All right. Oh, I know why it did that. That's better. Okay, so we'll have the Uber dictionary, not Uber, Uber dictionary. And then there should be like an extend. Uber dictionary.update my yeah, we'll say print length of Uber dict. See what this says here. 9,780 different keys. I think that worked. So we are going to write that. It's going to be with open, what are you? Go away. Path plus. Stop helping me. Okay. Yeah. Part of speech examples dot JSON. You know what? I don't think it needs to go there. We have a very poorly named stuff directory. And it can go there. And as F, I guess. It's going to be right. Encoding equals UTF of 8. And then JSON.dump uberdict. Yep, indent equals 4. And so this should give us a part of speech. Dump missing one parameter. Did I do the order right? No, I did not. That's what the underline was trying to tell me, you know. All right, run. Okay, part of speech examples. Looks good to me. Alright, then I don't think that we need this anymore. You know what, maybe we'll have like an archive just in case. Just in case there's something I'm not thinking of. So, part of speech examples, archive. I hate to delete something and then you find out that, oh, this didn't actually import correctly or something like that. You know what I mean? All right. So my speech examples equals, and we're going to say with open, what is it? It's the one that I just made. Part of, yeah. Okay. And then read encoding equals UTF-8 as file. Yeah, my speech examples right here. Eval k of v for k comma v in JSON.load.items. And we'll see what it looks like. Print my speech examples and go. Helps if I click on the right thing. Invalid syntax. Ox. Line 1, huh? Line 1. The very first line. That is not what I meant. Is this one that I manually fixed and I screwed it up? Okay, so this should be like that, that. Wow, that really got screwed up. So it's the same, but it needs to be escaped. Like that, right? Same thing. Okay, we've gotten all of them. I guess that wasn't too bad for thousands and thousands of parts of speech, having to fix 2 of them. All right. So now we have my speech examples. Now we just need to load the actual stories in. So we will go here, parts of speech. I believe that I've written code to load this already. So make curriculum write to MySQL. Oh, I started writing this the other day. This is not complete. Make curriculum. Okay, maybe I didn't. Like I know that I've written this before. This is ridiculous. Maybe I just haven't written it since I moved. Okay. So where's my list all files and directory? All right. Story POS list. Hey, that worked pretty well. So, okay, we need to have a story POS. I don't think this is what we want to do. Let's do class story, and then it will be, yeah. Yeah, and then this will be the POS file. So POS file, it'll need to remember that. And then it will handle the loading. So we'll say sister file. I did this very recently. I remember typing this. Sister file, prefix, and whatever. Go away. Go away. Go away. So sister file equals pos.file dot. Okay, here we're gonna say pos file equals pos file dot replace. And if there's any backslashes, we're going to replace them with forward slashes. And then the sister file is going to be replace POS with text. And then replace .json with .txt. And that should be pretty good. Assert os.path.exists. Sister file assert os.path exists POS file. Now, the story parts of speech is going to be, yep, this is right. Okay, self.text equals file.read. That's, yeah, it's getting a little bit scary here. So, part of speech file, part of speech is file.read. No, it's not file.read. JSON.load file. And self.pos, well, no, let's do it in line like we did up above. We'll do the comprehension thing. So this is going to be tuple of k. No, this is a list. So this is going to be a tuple of I for I in JSON.load. Yeah. And then part of speech set is just going to be the set of the POS. Oh, sorry. Self.pos. Okay. Okay, let's see if that we can load all of these. So story index just say stories equals dictionary, and then we'll say for file name in story POS list is stories of file name equals story FN. My God, what do you even need me for? Okay. Let's see what it looks like. Last file name equals none. Last file name equals FN, and then print stories. We can't print. There is no print method. What the hell am I talking about? All right. Def print. Print self dot part of speech. Okay. Print self dot, what else do we have? POS set, that should probably come after. Print self dot text. What else do we have? Self dot POS file. Yeah, that should be the last. Self dot POS file. So we will do stories of last file name dot print. Oh, look at that. It didn't auto-populate. Okay, now it shouldn't take that long because there's only about 12,000. The tiny stories that had like 800,000, that was taking a little bit too long. That was ridiculous. So it's still taking longer than I thought. In a sunny meadow, a little caterpillar named Sam started as a tiny egg. Sam had a big dream to fly and explore the world. Sam ate and grew, shedding old skin again and again. Finally, one day, Sam turned into a beautiful butterfly and soared high, showing that life's point is to embrace change and achieve our dreams. That is so sweet. All right, now we need to figure out a best first story. Now, first thing is it has to contain dog, because that's our marketing gimmick. And you know what? I don't even think people mind that it's a gimmick. People like dogs, so yeah, whatever. So, dog stories is going to be a list of keys. So for K in stories, we'll say K, comma, instead of V, let's do S. All right, so if dog in what? In S dot POS set, then dog stories dot append K, and we'll see how many there are. Print length of K. Run this. This would be better in a Jupyter notebook because it wouldn't have to load every time. Okay, so there's 65 stories in there that contain the word dog used as a noun. Now, I'm tempted to just get the shortest one, but I think we should probably try to figure out sentence complexity. So, yeah, I split into sentences before. Well, we'll figure this out. So, noun, dog, dog. So, now we have dog stories. Let's look at our desired parts of speech. I think I put that in here. So initial curriculum 101 words. So I don't know why this is a text file instead of a JSON file, but whatever. So my desired words equals that. So yeah, let's make this a set. And then we will go through and we'll figure out how many undesirable words are there. We probably need some sort of a scoring metric. So I think we need like a counter or something. Do I have every part of speech? Would be big. Part of speech mapping final. I think these are ordered. So yeah. Part of speech mapping final. So this should be pretty easy to load. We'll say with open part of speech, no. POS mapping final. Read encoding UTF as file, and we'll say POS mapping equals JSON.load, except that we have to do the eval thing. So we will do items. So k comma v for k comma v for k comma v in that, and then this has to be eval. Yeah, so probably what we should do is actually move this up here. So this is going to be our POS mapping, and then in here in the story initialization, we're going to say for p in self.pos set assert p in POS mapping. If it's not in there, then get very angry. POS to num is not defined. Where did I run the wrong one? No. POS mapping. Name POS to num is not defined. Where did I use it? I didn't use it. Build correct. I have used POS to num elsewhere, but not here. So it's angry about this, right? POS mapping not defined. That is true. Run. What is going on? Okay. POS mapping final. Oh. Right. Okay, so did I leave the initialize to 0? And I didn't. What are you not finding? That's interesting. Run. It's not. Oh, that is true. That is true. I did not put punctuation in there. Okay. if P of 0 doesn't punct, and P of 0 does not equal space, then we assert run again. Inherent okay. If P not in POS mapping, then print adding P to, no, don't. Okay, we've got to add P. So POS mapping of P equals length of POS mapping. That'll give us a mapping of these. I don't know. This is supposed to be every single word, so I mean this is a real word. I don't know why it's not in there, but yeah, so that should fix it. Holy crap. Nope. Nope. No. This is too many things. POS mapping final. I mean, I put everything in. If you told me that there was like a few words, proper noun. Okay. I don't know where these came from, but okay, whatever. All right. Let's not print. So then POS mappings, and then there's going to be a POS cost. POS cost is default dict of float. Well, no, let's do lambda. So if we don't know what something is, then it has a cost of 1,000. All right. Okay, now we need to figure out what the length of POS mapping is. All right, so let's go to the Python console. 25,833. Where's my Python console? I want my console. So import math, log of this, paste. Thank you. From math, import log. All right, so that would be like a cost of 10, whereas say 100 would be a cost of 4. So I like that. We are going to say POS cost equals default dict, and if we don't know what something is after everything, then we just give it this insanely high number. So 4k comma v in POS mapping dot items, we are going to say POS cost of k equals from math import log. This will just be log of 100 plus v. okay, unless it's in my desired words. Okay. If k in my desired words, then POS cost is going to be 0.1. Not 0, but, you know, not very much. Otherwise, it's going to be a lot. We don't want words that are not in our primary curriculum. And the rarer they are, the more we want them to cost. So that's the cost, and then we're going to have a gain, right? POS gain. And the gain by default is going to be 0. And then the POS, so here the POS gain of k is going to be equal to 1. And we want it to leave it at the default, so yeah, whatever. Now we want to generate scores for each of the stories. So story scores equals, what is it going to be? It's going to be the sum of the, well, we want the cost and the gain for each of them. I think we need a method. Story score, I guess. I don't know. And then I don't know, file name, I guess. And then we will grab it from the list of stories. You know what? I don't think that that's what we should do. We should actually pass a story here. So we're going to say for p in story dot POS set. And we're going to have cost equals 0 and gain equals 0. And then cost plus equals POS cost of p, and gain plus equals POS gain of p. And then we should be able to do that for every single story. For k comma v in POS mapping dot items. No. In stories. And then we will just have items equals that, and items dot append. Yeah, that's fine. Equals story dot score. Return cost comma gain. Well, we want the highest gain and the lowest cost, right? Let's do negative gain. Well, let's just keep it positive, and then we can evaluate it on a case-by-case basis. So items dot append, we're going to say cost comma gain equals story score of s, and then cost comma gain, file name and story. And I think we should put in a random number here, just so that if there's a tie, it won't break when we're trying to sort it. So for item in items, print item. And here we go. All right, so these are the highest gains. We want to know what has this is the highest cost, excuse me. We want to know what has the lowest cost. All right, now you notice these are almost identical as far as cost goes, but this is higher, gain. Now, probably early on, getting the absolute shortest story would be beneficial. So let's do length of s dot parts of speech, because I mean, like I said, we are talking about the absolute first administration. Now, in the future, we might not value that so much. Okay, so look at this. Length of 73. That's a lot of friggin' length 73. Okay, it really does go up. That just it seems like it's more stuck than it should be, but I guess it's real. You see, this is when I wish I were using the Jupyter Notebook, because I'd like to see a histogram of these. Oh, I guess we can see the range right here. Yeah, they're ordered, so I think that we can just eyeball this one. I mean, I don't need to set like a strict rule here. I mean, there's a gigantic jump, right? Like from here to here. So let's filter these. If item 0 equals 73 and item 1 is less than 3090, then print the item. Right? Run. Okay. So what I would like to know is, if we say any one of these is acceptable for a first story, then which one of these has the highest return on investment? I mean, they're all the same length, so we might as well get as many of our desired parts of speech as possible, right? Is it really the first one? It really is, isn't it? Do you see a higher one? Like, what are the odds? What are the odds that the very first one in the list is going to be the one that's the highest? Okay, well, let's just make sure. And item 2 is greater than or equal to 30. Okay. All right. I guess that works. Let's see what this story is that it's suggesting that we add. So selected story equals, well, whole thing, I guess. And we can just print it out right here. Print stories of selected story dot text, and we can see what it is. All right, key error. A lot of calculation just to print something out. Once upon a time, there was a magical door with a big wooden head on it. Magical? The door loved to tell jokes and make people laugh. One day, a little girl named Lily found the door and they became friends. Every day, Lily would visit the door to hear its funny jokes. They had lots of fun together and made everyone in town happy. Where is the mention of the dog? Oh my God. Okay. Let's try this again. That is not our selected story. Let's see if we can find something with 73. List object has no attribute items. Dogstory.items. S equals stories of K. Is that it? Is it stories? Where did we get dog stories from? Story, yes. Okay, we have some. Okay, as I was saying, this is our candidate, so selected story equals this. Can ignore all of this and show me the story. So stories of selected story dot text. Again, it is 73 long. How? Where did the quotes come from? Like, I thought I was being careful that time. One sunny day, a dog named Max and a cat named Lily decided to have a race. They called their bird friend Bella to be the judge. Lily dashed fast like lightning, but Max ran with all of his might. Bella cheered from above as they raced with delight. In the end, they all laughed and played, for friendships are what really stayed. I don't love this. I do not love this. I don't like that it rhymes. Not for a first story. Maybe later. I don't like that it mentions other animals. I would like the first story to be down to earth. It's like, they went to the park and they played ball. Maybe I need to write my own story. Maybe the absolute first story needs to be simpler. Max was a dog. He played ball. That kind of stuff. We could do that. So this entire thing is selecting a story, and we're just going to start. All right. Okay. Part of speech, spacey. Story, part of speech, spacey. We're going to do this. All right. Okay. Max is a dog. He likes to play ball. Right? Show me what you got. No module called NLTK. Well, I imagine not, because I told you to use spacey. Is this like really old code? Where is this? No, this is my main directory. Okay. Okay, we would like to reduce this down to just the part of speech, the word, and the lemma. So yeah, let's do that here. Token dot part of speech. Let's find. This is what we want. It needs to match my other. I hope I haven't thrown away useful information, but if I have at this point, I don't really know what to do. Okay. Max is a dog. He likes to play ball at the park. This introduces a, is, he, likes. Yeah. So run. Okay. So in this example, we would just take this text. All right. Okay. Sentence equals. And then part of speech equals. Okay, let's make sure that all of these are in there. So for P in part of speech, assert P in POS mapping. Let's see what it does. All right, it's angry about something. But the thing is I can probably fix it. All right. Structure. Yes, structure, that would definitely not be in there. While I do intend on looking at sentence structure, I'm not going to do it like this. That was one of my very early thoughts on how to deal with it. Okay, on a sunny day, a dog named Max. Yeah, don't need that. All of that can be commented out. So we need to build these sentences. Now I should have the example parts of speech, right? My speech examples. So assert P in my speech examples. Now, it's more likely that something would not be in there. No, we're good. Okay, so scene equals a set of everything that the student has seen. So show sentence, and then we will have text and parts of speech. And so for P in parts of speech, if P not in scene, then scene.add P, print, let's see here, we will have P, comma, we need to give the specific part of speech. Well, no. What it'll be is it will be, yeah, no, that was right. POS mapping of P. All right. And then at the end, we will just show the text. And then we'll put in a blank line. So, if you ever looked at like the Pimsleur German lessons, this is how it's set up. So it shows you words, and then it shows you a sentence, and then it shows you words, and then it shows you a sentence. But it doesn't show you words that you've seen before. So let's do show sentence. What just happened? I finally figured out what had happened. All right. Okay. Max is a dog. Right? Max is a dog. All right. And then he likes to play at the park. So this is what our lesson is going to, or this is the format that we're going to have. So he likes to play at the park. Now, obviously, as we introduce more parts of speech, the student will become familiar with them. Now, I would like to consider sentence structure moving forward, but for this absolute beginning, it's just trying to get on the board at all. And the student doesn't know any sentence structures yet, theoretically. So show sentence takes 2 positional arguments, but 9 were given. I think I did delete that without even thinking. Okay, so no, not POS mapping. My speech examples. And let's get rid of these other print statements too. All right. So, Max is running a boy, the dog. Okay. P1, my speech example. Run. So, Max is running. Max is a dog. I don't know if this can be broken apart. I don't know if it makes sense. Like, if I were trying to teach this, I don't want to save that. Don't save. Don't save. So Max, if I were explaining this to a foreign student, I would just say a name, a boy's name. Is. I mean, in this case, a direct translation really does make sense. And then you wouldn't say, yeah, you'd just be like a dog. Yeah, Max is, maybe Max is. That could be explained. Max is a dog. He see it's a little bit different when you get into further examples. To play. This is just the infinitive of to play. I don't know if these parts of speech examples are going to be useful at all. The ball. You say the ball or ball. Yeah, this was supposed to be my great idea. I hate it. We teach the phrase "at the park." To play ball. He likes to play ball at the park. These are the pieces of the sentence that can be broken down. Come back. Max is a dog. He likes to play at the park. And hopefully in future units it wouldn't exactly match, but like if the student doesn't know anything, then I mean, you almost have to do this, right? Then we start, variations off this, She likes, Mary is a girl, she likes to play chess at the restaurant, Substitutions. You know what I really think? I wonder why I'm doing this at all. Is that a bad thought to have? All right. So I guess lesson 1:1. Max is a dog. He likes to play ball at the park, and it teaches these parts of speech, right? And what sentence structure does it teach? Well, that's easy enough. We'll just say Python console x of 1 for x in that. Paste. Max is a dog. He likes to play ball at the park. That is not what I meant to do. Why does my cursor not work? Yeah, proper noun, auxiliary, determiner, noun, pronoun. Okay. We're going to say, go to the beginning. Join all right, so it teaches the sentence structures. Okay, Max is a dog. He likes to play ball at the park. I just realized something. This could be simplified. He likes to play at the park. Right? And then you can introduce to play ball, to play chess, to play mind games, that kind of thing. So, yeah, okay, I think that sounds good. Let's see what it says. I'm curious what it sounds like if we put this through a voice-to-text thing. Let's do it. OpenAI TTS. All right. Run. My experience thus far has been very positive with the TTS stuff. So, at least from OpenAI, it is the best. I mean, it really sounds like a real person, and I've never thought that of any other text-to-speech system ever. Not one single one.
Max is a dog. Max is a dog. He likes to play at the park. He likes to play at the park.
Okay, it didn't implement the pauses like I wanted it to do, so that made it sound kind of weird. But if you just give it just a straight up sentence, it sounds pretty good. I need to break apart the individual pieces. Yeah, you know what? I'm not unhappy with this, but I think what I wanted to do was make a script and then just push the go button and have it kick out like 500 lessons, and that's not going to be the way it's going to happen. I'm going to have to use some kind of data management system to keep track of what parts of speech I've taught and the sentence structures that I've taught, and then do incremental increases in sentence complexity while reviewing parts of speech. I really like the Fibonacci scale. I think that works pretty well. And the idea that every new part of speech that's introduced needs to be explained. And if there's a sentence structure that is more than, one part of speech different, then it becomes a new example sentence. And that needs to be reinforced more strongly than a simple variation off a previous sentence that the student supposedly already knew. So that's the idea. Whether or not I can make it a reality, that's a different story. So, anyways, see ya.